Hello everyone. Hello. I welcome you all in this session of paper discussion. Live mode it is. So paper discussion of PI paper. PI production industrial took place today and already Hindi analysis is going on. So in this session we are going to deal with the English analysis, English mode of analysis, and only English medium will be there. So those of you who are comfortable in English and also those of you who have not able to see the previous analysis of the paper, I mean in the Hindi mode, please, I would like you guys to come and join me. So I would request you guys that please share this session amongst all of your groups, Telegram groups, channels, your friends, peers, everybody. Do this and share it amongst everyone. Please share it. And we really want you guys to come up and have this discussion, because this discussion is going to be helpful in your upcoming exam that is on 13th. So I would urge you guys to please share it amongst everyone, and we'll keep it very crisp and precise. As you can see, I have written the questions prior to the discussion, and we don't have to keep wasting in time in writing and all. So I have written it already for you guys, and let me tell you, these are memory based questions. For thermodynamics, we could only find one, because when we communicated to the students who have given us this question, we only got one question of thermodynamics. So of thermodynamics there is one which will be dealt by me, of course, and afterwards we'll be having, just after this session, we'll be having Amit Maurya sir. He'll be taking one only FM question we found, and that too is too damn easy. This one is also very easy. If you have studied here long on this channel itself, thermodynamics and fluid mechanics, you'll be able to solve those questions. Okay, after that we'll call upon Raman and Bansal sir, then production and industrial will keep on going as we know. Okay, so please share it. We are going to start just in a minute or two. Please share it amongst everyone. Good. I don't want to delay too much, but I want at least to more and more of you to be present, and we shall start then. Meanwhile, those of you who are present, please see, if you have tried this question, if you have attempted the exam, you must have tried this question, and this question is simply entropy calculations question, and this is based on TDS equations. Now the only catch being that in the question the examiner is specifically mentioning irreversible process. So please read the question carefully. Air at an initial temperature and pressure of 15 degrees Celsius and 1 bar is heated in an irreversible process, right? It is heated in an irreversible process. The final temperature and pressures are this much. The change in entropy for the process will be. Now let me tell you guys, what is the pressure? P1 is 1 bar. What is the temperature? T1. It is how much, bacha? 15 degrees Celsius. We want it in Kelvin, so we have to add 273, hence it becomes 288 Kelvin. Now it reaches all together to P2, which is 2 bar, and the temperature T2, which is 303, means 576 Kelvin or 303 degrees Celsius. Now we have already seen that if we want to calculate delta S, if delta S is to be calculated, if change in entropy is to be calculated, how do we proceed with that? We have to proceed with TDS equations. And how do we go along with TDS equations, bacha? For TDS equations, we simply know that there are two equations. What are those? TDS equals du plus pdv, and DDS equals to dH minus VdP. dH minus VdP. Which one would we use here? We won't be using this one. Why? Because changes in temperature and pressure are given. So we have been given the temperature and pressure changes. So hence we'll use this. If volume and temperature changes were given, we would have used the other one. So why we are using this one? Because the changes in temperature and pressure are given. That's why we are using this equation. It is as simple as it can be. Now for an ideal gas, TDS equals to M, this will be capital H, in fact, M Cp dt minus V by T dP. Yes or no? Alright, V by T, if T goes there, dt by T. It becomes like this. Now what? So this ds shall become m Cp dt by T minus mr dp by p. Is it not? Of course it is. Yes or no? Why? Because PV equals to MRT. So hence if you want to calculate V by T, you have to do this. That's all it is required. Now what would you do? You would simply integrate it upon integrating. So when you do the integration, upon doing the integral part, it becomes ds 1 to 2 will be delta s, which is equal to s2 minus s1. Now this shall be m integral mcp integral dt over t from T1 is 288 Kelvin 15 degrees Celsius and 576 till it is going, minus mr dp by p. It is going from 1 bar to 2 bar. Now since the mass is not given, unity, right? We have to assume it that it is in unity. Am I right? So hence our delta S shall become Cp is 1.005 ln 576 over 288 minus R is 0.287 ln 2 over 1. Have you guys done it in this way, in this manner? Of course you might have done it in this manner itself. So the answer which you guys shall be getting, let me solve it for you, and I believe that most of you might have done it in a very precise and concise manner. So let me do it for you. Just a minute guys, I am just coming up with the solution. 576 over 288, it is 0.4976 or 4977. So let me write the answer here. Delta S is, or S2 minus S1 is 0.4977 kilojoule per kg of Kelvin. Why are we using kilojoule per kg? Because mass is not given and we have assumed it to be as unity, right? So this is the question which was there from your thermodynamics. It is very simple, and we have already discussed these kind of questions in our crash course which was dealt on this global channel as well as in the Hindi channel also, right? So this is from my side, and I would like to say that Amit Maurya sir, you are ready. I know that you are ready, sir. So I'm just going to end it from my side. You have to take it on, right? Okay, sir. So Amit Maurya sir will be coming now, and he'll be taking the fluid mechanics question. It is very simple question, just like this only. Simple formula based approach you have to do. Maurya sir is going to be there, and Avinash Bhaiya, you are handling the session. Kindly communicate as well if there is some miscommunication between me and Maurya sir in terms of this session handling and all. So please do it. I'm just ending on my side. Okay. Thank you so very much, guys. Love you all, and please keep studying and keep sharing as well. Okay. Please do it. Just a moment.
Hello, hello. Hello, am I audible? Please confirm. Hello, hello, hello. Am I audible? Please confirm. Hello. There was some technical issue. That's why it got some delayed. Now we are starting. If I am audible, please confirm. Then I will start the session. Right now. Okay, sir. Just I am starting. Uh, I, I will discuss strength of material, machine design and theory of machine part. There are 4 questions from strength of material and machine design part and only 1 question from theory of machine part. I am first starting with strength of material and machine design part. This is first question. What question is saying? Yielding starts in a material when principal stresses are 100 megapascal, second principal stress is 100 megapascal and third principal stress is 200 megapascal. What is all three principal stresses? First principal stress, that is sigma 1, is 100 megapascal. Second principal stress, that is sigma 2, is 100 megapascal, and third principal stress, that is sigma 3, is 200 megapascal. And in this stress condition, yielding of the material is starting. In this stress condition, yielding of the material is starting. Okay, what we have to find? We have to find, as per von Mises criteria, yield stress of the material will be. As per von Mises criteria, yield stress of the material will be. What is yield stress? If any material is subjected to 1D tensile stress, suppose if any material is subjected to 1D tensile stress, then value of 1D tensile stress at which yielding of material starts is known as yield strength of the material. So suppose value of 1D tensile stress at which yielding is starting is sigma f. Then sigma f will be yield strength of the material. And we have to find yield strength of the material as per von Mises criteria. As per von Mises criteria means we have to find yield strength of the material by using distortion energy theory of failure. Because von Mises criteria means distortion energy theory of failure. How we will find or how we will proceed? What we will do? First we will find distortion energy per unit volume for actual stress condition in which yielding of the material is occurring. Then we will find distortion energy per unit volume for 1D tensile stress condition. And we will equate both distortion energy. And by equating both distortion energy, the value of sigma f which we will got will be yield strength of the material as per von Mises theory of failure or distortion energy theory of failure. Okay. For that, first we should know what is the formula to calculate distortion energy per unit volume. And formula to calculate distortion energy per unit volume is 1 upon 6g, where g is modulus of rigidity. In bracket, sigma 1 square plus sigma 2 square plus sigma 3 square minus in bracket sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1. This is the formula to calculate distortion energy per unit volume. Now what we will do? First we will find distortion energy per unit volume for actual stress condition. Then we will find distortion energy per unit volume for 1D tensile stress condition, and then we will equate both the distortion energy. What will be the distortion energy per unit volume for actual stress condition? It will be 1 upon 6g, and under actual condition value of sigma 1 is 100, sigma 2 is 100 and sigma 3 is 200. We will put these values in this equation. Sigma 1 is 100 megapascal plus sigma 2 square. Sigma 2 is also 100 megapascal plus sigma 3 square. Sigma 3 is 200 megapascal minus in bracket sigma 1 sigma 2. Sigma 1 is 100, sigma 2 is 100 plus sigma 2 sigma 3. Sigma 2 is 100, sigma 3 is 200 plus sigma 3 sigma 1. Sigma 3 is 200 and sigma 1 is 100. This is distortion energy per unit volume for actual stress condition. Now we will calculate distortion energy per unit volume for 1D tensile stress. Under 1D tensile stress, sigma f, value of principal stress, all the principal stress will be, one value of principal stress will be sigma f and another two principal stress will be 0. If any material is subjected to 1D tensile stress, suppose any material or lamina is subjected to 1D tensile stress sigma, then value of all the principal stress will be sigma 0 and 0. Since this material is subjected to 1D tensile stress sigma f, therefore value of all principal stress will be sigma f 0 and 0. I'm considering sigma f as sigma 1 and other two principal stresses are sigma 2 and sigma 3. Now we will put value of sigma 1 equal to sigma f, value of sigma 2 equal to 0 and value of sigma 3 equal to 0. Then we will get distortion energy for this under 1D tensile stress condition. And what we will got? 1 upon 6f, sorry 6g in bracket. Sigma 1 is sigma f, then sigma f is square, plus sigma 2 is 0. This part will become 0. Sigma 3 is 0, so this part will also become 0. In sigma 1, sigma 2 is 0, so this part will become 0. Out of sigma 2, sigma 3 both are 0, so this part will also become 0. In sigma 3, sigma 1, sigma 3 0, therefore this part will also become 0. And it will come 1 upon 6g in bracket sigma f square. And after equating both this distortion energy per unit volume, we will get value of sigma f and it will come 100 megapascal. You have calculator, you can check it. It will come 100 megapascal. So yield strength of the material for this condition by using von Mises criteria will be 100 megapascal, and it is also asking in unit megapascal, so its answer will be 100 megapascal. Okay, this was first question. Okay, Paul. Okay, this was the first question. Now I am moving to next question. Be ready. This is second question. It is the question from torsional or torsion in shaft. What question is saying? A shaft used to transmit power of 10 kilowatt. Well, power is 10 kilowatt. So in SI unit it will become 10,000 watt. Shear yield stress of the material is 150 megapascal. Shear yield strength means shear yield strength of the material is given in question, and suppose I am denoting shear yield strength of the material as tau f, and shear yield strength of the material is 150 megapascal or Newton per mm square. Mathematically megapascal or Newton per mm square both are same. Okay, and FOS equal to 2, factor of safety, means we have to design the shaft by using factor of safety 2. Now the shaft rotates at speed 1440 rpm. So rotational speed of the shaft is 1440 rpm. So we can convert this speed into radian per second and it will become 2 pi n by 60 in radian per second, and value of n is 1440 rpm. So this is rotational speed in radian per second. Then we have to find safe diameter of the shaft by using static strength. Static strength means we have to design the material by considering shaft is in static condition, and in static condition generally we consider criteria of failure either ductile either yield strength or ultimate strength. If material is ductile, then we will consider criteria of failure, then we will consider yield strength as criteria of material. If material is brittle, then we will consider ultimate strength as criteria of failure. Since shear yield strength of the material is given, means material is ductile, and since material is ductile, therefore we will consider shear yield strength as criteria of failure. And how we will design? What we will do, since shear yield strength of the material is given, so first we will find expression of maximum shear stress in the shaft, and this maximum shear stress of the shaft should be less than equal to shear strength upon FOS. Should be less than equal to shear strength upon FOS. And since we are designing, we are calculating limiting diameter or limiting value of diameter, then to calculate limiting value we will use equal sign. So what we will do, we will equate actual maximum shear stress to the shear strength upon FOS to calculate limiting diameter of the shaft. For that, first we need to calculate what is the expression of maximum shear stress. And how we will calculate? Since this shaft power transmitted by the shaft is 10,000 watt, and speed 2 pi n by 60, that is 2 pi into 1440 upon 60 radians per second. So by using power and omega, we can calculate how much torque shaft is transmitting. And how we will calculate? What is the formula to calculate power is? Formula to calculate power is omega into torque. Power is 10,000 watt. Omega is 2 pi 1440 divided by 60 radian per second into torque. So from this equation we will get how much torque shaft is transmitting, and it will come, it is coming 10,000 into 60 divided by 2 divided by pi divided by 1440. Torque is coming 66.314559 Newton meter. Okay. While using this equation, I will take units like this. I will use unit for force as Newton. For dimension, I will use unit mm. So SI unit of torque is Newton meter, and I am taking force as Newton. It is already in Newton, but I am taking dimension in mm. Therefore, I will convert this meter into mm, and 1 meter is equal to 1000 mm. So how much it will come in Newton mm? 66314.559. Newton is already Newton, and to convert meter into mm we have to multiply 1000. So it will come into 1000. 66314.559 Newton mm. Now, since shaft is subjected to torsion moment, so we can calculate expression of maximum shear stress. And for circular shaft under tension, formula to calculate maximum shear stress is 16T upon pi d cube. Okay, what is the value of T? It is 66314.55962 Newton mm divided by pi t cube. Okay, and this maximum shear stress should be less than equal to tau f, that is shear strength, upon FOS. And to calculate limiting diameter, we will use equal sign. So it is 16 into 66314.55962 divided by pi d cube is should be less than equal to tau f is shear strength, which is 150 Newton per mm square, and factor of safety of 2. From this equation, we will get limiting value of diameter, and it is coming into 60 divided by pi into 2 divided by 150, then cubic root. Limiting value of diameter is coming 16.513 mm. Okay. Actual diameter of the shaft should be either 16.513 or greater than 16.513. But we have to calculate limiting value, and its limiting value is coming 16.513 mm. So examiner is also asking in mm. So answer will be 16.513. Okay. This was second question of strength of material. Okay. Hello Moria sir. Now I am moving forward to next question. This was question number 2. Now this is question number 3. This is very easy question. What examiner is saying, if G denotes shear modulus of isotropic material. Shear modulus means modulus of rigidity. Modulus of rigidity or shear modulus of the material is G. Then what will be the maximum possible value of Young modulus? Okay. What will be the maximum possible value of Young modulus? Okay. Generally we denote Young modulus as E. And we already know relation between E and G. What is the relation between E and G? E is equal to 2G in bracket 1 plus mu, where G is given because shear modulus of the material is G. Examiner is saying. Now, if value of G is given, then E will be maximum when mu is maximum, because from this relation you can easily relate, when value of mu is more, then value of E will also be more. So we have to calculate maximum possible value of E. Here MP means maximum possible. For that we will take maximum possible value of mu. We will take maximum possible value of mu. And since material is isotropic, and we already know for isotropic material maximum possible value of mu is 0.5. For isotropic material mu can never be more than 0.5. So maximum possible value of mu is 0.5. So to calculate maximum possible value of E, we will take maximum possible value of mu, which is 0.5. And by putting mu equal to 0.5 in this equation, we will get 2G in bracket 1 plus 0.5. We will get maximum possible value of E. It will come 1.5 into 2, 3 into G. Okay. So maximum possible value of E is 3 into G. Which option is coming? Sir, option D. 3 into G. So this was the next question. Now I am moving forward to next question. This question is from thick cylinder. Thick cylinder is not in the syllabus of GATE mechanical, but it was in the syllabus of GATE PI. So this question is from thick cylinder. What examiner is saying? A thick cylinder has inner diameter of 20 mm. Inner diameter 20 mm means inner radius will be, suppose I am denoting inner radius as Ri. Since inner diameter is 20 mm, so inner radius will be half of 20, that is 10 mm. Next, outer diameter of 40 mm. outer diameter, suppose I am denoting outer radius as R0. Since outer diameter is 40, then outer radius will be 40 divided by 2, that is 20 mm. Now, it is subjected to internal pressure of 100 megapascal. In thin cylinder, only internal pressure is coming, no external pressure is coming. Because examiner is saying it is subjected to internal pressure of 100 megapascal, means internal pressure is coming. And value of internal pressure, suppose I am denoting internal pressure as Pi. So value of internal pressure is 100 megapascal. Mathematically, megapascal or Newton per mm square is same unit. So it will be 100 Newton megapascal or Newton per mm square. And no external pressure is coming, because examiner is saying only it is subjected to internal pressure, means no external pressure is coming. So can we say value of external pressure, suppose I am denoting external pressure as P naught. So value of external pressure will be 0 megapascal or Newton per mm square. Okay. Now we have to take here sign convection is given. We have to consider tensile stress as positive and compressive stress as negative. Means we have to, while solving question, we have to use proper sign convection, because examiner is saying take tensile stress as positive and compressive stress is negative. Then we have to find sum of radial stress. Suppose I am denoting radial stress as sigma r, and hoop stress. Suppose I am denoting hoop stress as sigma h. So we have to find sum of radial stress and hoop stress in megapascal at radial distance 15 mm. So at radial distance 15 mm, we have to find sum of sigma r and sigma h. And while calculating this sum, we have to consider tensile as positive and compressive stress as negative. Okay. Okay. In thin cylinder, what is the formula to calculate hoop stress? We only in thin cylinder, to solve the problem, we need to remember only two equations. One formula to calculate hoop stress, and second formula to calculate radial stress. In hoop stress, formula to calculate hoop stress is A plus B by R square, where A and B are constant, and R is radial distance. And formula to calculate radial stress in thick cylinder is A minus B by R square. Very simple equation. For hoop stress, A plus B by R square, and for radial stress, A minus B by R square, where A and B are constant. Okay. And while using these two equations, we have to consider tensile stress as positive. If sigma is tensile, we will take it positive. If compressive, we will take it as negative. If sigma r is tensile, we will take it as positive. If sigma r is compressive, we will take it as negative. So we have to use proper sign convection while using these two equations. Suppose I am denoting this equation as equation 1 and this equation as equation 2. Okay. What is our objective? Our objective is to find sum of sigma h plus sigma r at radial distance 15 mm. So we have to find sigma h plus sigma r. And to calculate sigma h plus sigma r, we will add equation 1 and 2. We will add equation 1 and 2, then LHS will become sigma h plus sigma r. So for to calculate sigma h and plus sigma r, we are adding 1 plus 2. And equation 1 plus, when we will add equation 1 and 2, it will become, LHS will become sigma h plus sigma r equal to, RHS will become A plus A, means 2A, and plus B by R square minus B by R square. In first part, B by R square is coming with first plus sign. In second part, B by R square is coming with minus sign. So both term will get cancelled. So sigma h plus sigma r will become 2A. So can we say sigma h plus sigma r is constant, because A is constant? So examiner is asking this summation in R equal to 15 mm. But whether it is asking in R equal to 15 mm or R equal to Ri or R equal to R naught or R equal to 16 mm, in all value of R, this summation is constant, which is equal to 2A. So to calculate this summation, first we need to find value of A, and by doubling A, we will get sigma h plus sigma r. Okay. So first our objective will, now our objective is become, first calculate value of A. And how we will calculate value of A? Here A and B are constant, and to calculate A and B, we need some boundary condition. And what are the boundary condition? Examiner has given internal pressure and external pressure. Only you need to remember one thing. Magnitude of radial stress will always be equal to pressure. Means in inner layer, value of radial, magnitude of radial stress. Currently I am talking about magnitude, not nature. And in inner layer, radial stress, value of radial stress will be 100 megapascal, because internal pressure is 100 megapascal. At outer layer, magnitude of radial stress will be 0 megapascal because at outer layer pressure is 0 megapascal. And nature of radial stress will always be compressive. Why? Because pressure is nature of pressure is always compressive, because pressure always act in inward direction. So nature of radial stress will be compressive, and its magnitude will be equal to pressure at that layer. So can we say radial stress in inner layer, that is sigma Ri, its magnitude will be 100 megapascal because internal pressure is 100 megapascal, and nature will be compressive, and since we are considering compressive as negative, it will be minus 100. Okay. Similarly, at outer layer, value of radial stress will be 0 megapascal because at outer layer pressure is 0, and we need not to use minus sign here because minus 0 is 0. So inner radial stress at inner layer is minus 100 megapascal, and in outer layer is 0 megapascal. Okay. So these are the boundary condition. By using this boundary condition, we can calculate value of A and B. How? First boundary condition is at inner layer. Inner layer means at R equal to Ri, and value of Ri is 10 mm. Radial stress, that is sigma Ri, is minus 100 megapascal. So in the formula of radial stress, we will put radial stress equal to minus 100, and we will put value of R equal to 10 mm. Then we will get one more equation, and this equation will be minus 100 equal to A minus B by R square, and value of R is 10 square. Suppose I am denoting, suppose this is equation 4. So I am considering this equation as equation 4. Similarly, at outer layer means at R equal to R naught, and value of R naught is 20 mm. At outer layer radial stress is 0. So what we will do, in the expression of radial stress, we will put sigma R equal to 0 and R equal to 20 mm. We will get one more equation. Suppose this equation is equation 5. It will be sigma radial equal to 0 equal to A minus B by R square, and at outer layer value of R is 20 square. Now by solving equation 4 and equation 5, we will get value of A and B. Okay. So I am solving these two equations. Now this is pure mathematics. We have to solve this equation 4 and 5, and we have to calculate value of A and B. How we will calculate? For that, first I am what I am doing, I am subtracting equation 4 and 5. By subtracting equation 4 and 5, A will get cancelled. Then we will get value of B. I am subtracting equation 4 minus 5. Then LHS will become minus 100 minus of 0. So it will become minus 100 minus 0 means minus 100 equal to RHS will become A minus A. Both A will get cancelled. Now this part is minus B upon 10 square. And this will become minus equation 5. Na? So minus minus will become plus. So it will come plus B by 20 square. By solving this equation, we will get value of B, and it will come minus 100. I am taking minus B common, then it will become 1 upon 10 square and minus 1 upon 20 square. So it will become minus 100 equal to B minus B into, both minus will get cancelled, in bracket 1 upon 100 minus 1 upon 20 square, 3 divided by 400. So value of B will come 40,000 divided by 3. Now I am putting value of B in equation 5. So then we will get value of A. Value 0 equal to A minus B. B is 40,000 divided by 3 and divided by 20 square. So from this equation we will get value of A. It is coming 100 divided by 3. Now our objective is to calculate sum of hoop stress and radial stress, and formula to calculate sum of hoop stress and radial stress is 2A, and we have to calculate this summation is at R equal to 15 mm, but this summation is constant because it is coming equal to 2A. So at all radius the value of sigma h and plus sigma r is equal to 2A, and A is constant. Therefore for all radius, means for all value of R, this summation will come as constant. So at R equal to 15 mm also this summation will be equal to 2A, and value of A is 100 divided by 3. So it will come 200 divided by 3, that is 66.667 megapascal or Newton per mm square. So summation of hoop stress plus radial stress is 66.667 megapascal, and examiner is also asking in unit 6 megapascal. So its answer will be 66.667. Okay, this was next question. Okay, so we have completed strength of material part and machine design part. Now I am moving to theory of machine part. In theory of machine, only one question has come. Now I'm moving forward to theory of machine part, and this is last question. So Maurya sir, I think next section will be taken by Maurya sir. Okay. In a slider crank mechanism, the crank rotates at 60 rpm. Suppose this is slider crank mechanism. In this slider crank mechanism, this crank is rotating with constant speed, and its speed is 60 rpm. Suppose I am denoting speed of crank in rpm as capital N, and it is 60 rpm. We can convert rpm into radian per second. It will be 2 pi n by 60 in radian per second. The radius of the crank is 30 mm. Suppose I am denoting radius of crank as r. So value of r is 30 mm. And length of connecting rod is 120 mm. Suppose I am denoting length of connecting rod as small l, and it is 120 mm. The average velocity over one revolution, average velocity of piston, here word piston has left, of piston, we have to find average velocity of piston, piston means slider, in mm per second over one revolution of crank. We have to find only average velocity of piston for one revolution of crank. And how we will find average velocity of piston for one revolution of crank? We have to find not instantaneous velocity, we have to find average velocity. And how we will find average velocity? Formula to calculate average velocity is distance upon time. Because we have to find only if we have, our objective is to find instantaneous velocity, then we will calculate instantaneous velocity by differentiating displacement, and it will be dx by dt. But we have to find average velocity of piston, and formula to calculate average velocity is distance upon time, and we have to find average velocity for one revolution of crank. So what we will find? First we will find in one revolution how much distance piston is traveling. In one revolution of crank, how much distance piston is traveling. Okay? For one revolution of crank, how much distance piston is traveling. And T is will be how much time crank or piston is taking to complete one revolution. How much time crank or piston is taking to complete one revolution. So we have to find how much distance piston will travel during one revolution. Then we have to find how much time it will take to complete one revolution. Okay. So first I am calculating how much distance piston will travel in one revolution of shaft. So in one revolution of shaft, suppose stroke length of the piston is capital L. So in one revolution of shaft, piston will travel 12 distance. Because in one revolution piston will complete 2 stroke and stroke length is L. So in complete one revolution, 2 stroke of the piston is completing, and in one stroke piston is traveling L distance. So in 2L distance, that is in one cycle, piston will travel 2L distance. For that we have to calculate stroke length of the piston, and stroke length of the piston in slider crank is always equal to twice of crank radius. Here crank radius is 30 mm, so stroke length will be 60 mm. You should know this formula. Okay. So in one revolution piston will travel 2L distance. L is 60 mm, so this distance will come 120 mm. So in one revolution of crank, piston will travel 2L distance, that is 120 mm distance. Okay. Now we have to calculate in one revolution how much time it is taking to complete one revolution. And how we will calculate? Here speed of crank is constant, that is omega is constant. Okay, angular speed of crank will always be equal to d theta by dt. But if speed is constant and here omega is constant, then we can write this formula as del theta by del t, where del theta is angular displacement and del t is time interval. And why I am using this formula to calculate omega? Because time interval. because angular speed of the crank is constant. Okay. From this equation we will get del T as del theta by omega, where del theta is angular displacement, del T is time, and omega is constant angular speed of the crank. And we have to find time to complete one revolution of the crank, that is time to complete one cycle. Okay. So time, I am denoting time to complete one revolution as capital T. Okay. In one complete revolution, crank will rotate 2 pi angle rotation. The crank will rotate 2 pi angle. So in one complete revolution, angular displacement will be 2 pi. Okay. And what is the value of angular speed? It is 2 pi n by 60, and value of n is 60 rpm. So it will come 2 pi n by 60. 60 will get cancelled. It will come 2 pi radian per second. So what is the value of omega? It is 2 pi radian per second. So by solving this, we will get 1 second. So time to complete one revolution of the crank, or time to complete one cycle, is 1 second. Now we can calculate average velocity of the piston for one cycle. In one cycle, piston is traveling d distance, which is 120 mm. Time taken by piston to complete one cycle is 1 second. So it is 1. And so this is average velocity, and it will come in mm per second, because we have taken distance in mm and time in second. So average velocity of the piston in one cycle is 120 mm per second. Okay. This is average velocity. So average velocity, examiner is asking also in mm per second, and it is coming 120 mm per second. Okay. So this was the theory of machine design and strength of material part. My part has completed. Now next session will be taken by Amit Maurya sir. Okay. After my session will automatically get switched, and Maurya sir will take next section. Okay. I am coordinating with Maurya sir. Okay.
हाँ जी सर।
सर मैं स्टॉप कर दूं क्या?
1 मिनट रुक जाइए सर, थोड़ा सा आप वहाँ पे 1 मिनट का रुकिए, अभी स्टॉप मत कीजिएगा, मैं मौर्य सर को बोलता हूँ, है ना?
हाँ सर।
1 मिनट रुकिएगा आप।
हाँ। Okay. We are coordinating with Maurya sir. Just wait for 1 to 2 minutes. Only just for 1 minute. Next session will get start. Yes sir. हेलो।
हाँ जी सर।
हाँ सर।
जी सर, आवाज आ रही है मेरी?
जी सर।
जी सर, स्टॉप कर दीजिए आप, है ना?
ठीक है सर, मैं कर दिया ना स्टॉप।
जी जी जी।
Okay, so good evening all of you, and welcome on GATE Academy. Good evening all of you, good evening. So just me confirm the audio and video. Please confirm audio and video. Is audio is audible? Okay, so let me write the question. Good evening all of you, good evening, and welcome on GATE Academy. Okay, so there is one question. Okay, so there is one question asked in a PI paper, and one small question for I think 1 marks. Okay, so let me write the question first, and then we should discuss the solution. So what is the question? In question, they should given the kinematic viscosity. Okay, the value of kinematic viscosity should be the 1 into 10 raised to the power minus 6 meter square per second. Okay, kinematic viscosity should be 1 into 10 raised to the power minus 6 is flowing through a circular horizontal pipe of diameter is given as 8 meter. Diameter is given as 8 mm, sorry, 8 mm. Horizontal pipe. If the flow is a fully developed laminar. Clear? In question, they should mention that flow should be the fully developed laminar. Clear? Flow should be the fully developed laminar. Flow should be the fully developed laminar. Then, if the flow is laminar and fully developed with a maximum axial velocity, so they should given the maximum velocity should be the 0.5 meter per second. Clear? Then they asking to find the Reynolds number. Clear? What is the Reynolds number? So kinematic viscosity is given 1 into 10 raised to the power minus 6. Diameter is given as 8 mm. Fully developed laminar should be mentioned. Maximum velocity is 0.5 meter per second. What is the value of Reynolds number? Clear? What is the value of Reynolds number? And we should know that the maximum velocity is what? Clear? In a pipe flow, clear? In pipe flow, if there is a fully developed laminar, you can say the velocity profile should be the parabolic in nature. Clear? And at center point, the velocity is a maximum. At this point, you can say velocity should be the maximum. Clear? And what is the Reynolds number? Reynolds number based on a diameter. Because in pipe flow, the characteristic dimension should be the diameter. Clear? So you can say Reynolds number is the rho u mean velocity and multiplied by diameter. Clear? LC the diameter and dynamic viscosity. And you can also write the mean velocity, diameter, dynamic viscosity divided by a density. So this should be the mean velocity, diameter and kinematic viscosity. Clear? Kinematic viscosity. Clear? So we know that in case of pipe flow, if there will be the fully developed laminar. Clear? In question, they mentioned that the flow should be the fully developed laminar flow. So in case of fully developed laminar flow, we know that the mean velocity of the flow is the half of the maximum velocity. Clear? And maximum velocity is what? That will be the 0.5 meter per second. Clear? So mean velocity is max divided by 2. Clear? Max divided by 2. So we will put the magnitude. U mean will be the 0.5 divided by 2 and multiplied by diameter. Diameter is given as 8 mm. Clear? So you can write 8 into 10 raised to the power minus 3 and kinematic viscosity is what? That will be the 1 into 10 raised to the power minus 5, I think. Clear? Minus 6. Sorry. This should be the minus 6. So I think the value should be the, we will calculate. So this one is 0.5 divided by 2 multiplied by 8 into 10 raised to the power minus 3 and divided by, you can say 10 raised to the power minus 6. This should be the 2000. Clear? The value of Reynolds number based on a diameter is 2000. Clear? The value of Reynolds number is 2000 for this particular question. Okay, this will be the value of a Reynolds number. I think this question is asked in for 1 marks. Clear? 1 marks. Maybe it will be at 2 marks. But I hope this is straightforward, formula based a question. Clear? So the Reynolds number should be the 2000. Okay. So this is one question which is asked in GATE API, and I hope you get a concept for this question. Okay. So let me hand over to this session to the next teacher. So please once confirm the solution for this. Are you getting the? Let me hand over to this. Okay, so next will be the session by Aditya Pal sir. Okay, so let me hand over to Aditya sir.
Hello everyone, how are you? I hope all of you are fine, and I hope today you have given your best in your exam. So let's discuss today's session. In today's session, just a minute, I have to minimize the volume. And I hope today you have given your best. Yes. Good evening to all. Good evening. So let's start today's session. Okay, let's start today's session. Let's solve some problem. Let me find out the question which we have to discuss. So tell me about your GATE paper. Do you like the paper? Tell me, how was your paper? Yes, tell me, how was your paper? Just a minute. यार कम से कम वो लिंक तो दे दिया करो ना यूट्यूब की यूट्यूब जिस पे चल रहा है ग्लोबल की ग्लोबल का लिंक भेज दो फटाफट मुझे चलिए तो स्टार्ट करते हैं आज का सेशन तो सो लेट्स स्टार्ट टुडेज सेशन सो टेल मी अबाउट योर पेपर टेल मी अबाउट योर पेपर डू यू लाइक द सेशन आई मीन डू यू लाइक द पेपर हाउ वाज योर पेपर टेल मी अबाउट योर पेपर यस माय डियर स्टूडेंट टेल मी अबाउट योर पेपर टेल मी योर एक्सपीरियंस फर्स्ट टेल मी योर एक्सपीरियंस फर्स्ट ओके लेट्स स्टार्ट टुडेज सेशन Let's start today's session. Okay. Yes. Yes. Okay. Where? Yes. The first question. Okay. The first question is here. The first question is here. See the question. See the question.
right? See the question. What the question is saying. First question in the production. The absolute deviation of 8 point, just a minute, the absolute deviation of 8 point, yes, the absolute deviation, okay, of 8 points, from datum line, okay, from datum line of a surface R, okay, are what, 10, 15, 12, 10, 13, 12, 20, right, and 25 micrometer. The root mean square value, the root mean square value of the surface roughness, okay, of the surface roughness in micrometer, okay, is, yes, the question is pretty easy. How we have to solve? We know that we know that the root mean square value, okay, RMS is what? That is a root of summation of the value of the roughness from the datum line, okay, summation of divide by 1 by n, that is the number of data. Am I clear? Yes, tell me, is that formula is clear to you people? Is that formula is clear to you people? Yes or no? So you have to just add square and add 10 square, 15 square, plus 12 square, plus 10 square, plus 13 square, plus 12 square, plus 20 square, plus 25 square, divide by 8. Yes or no? Yes or no? My dear, you will get 15.43. 15.43 micrometer. Yes? Clear? Tell me. Clear? So this is the answer. Now, let me see the next question. The next question is, that is the question number 2. It's a pretty simple question. Okay, it's a pretty simple question. What he is asking, a single point cutting tool, right? A single point cutting tool with zero rake angle, okay, is used for orthogonal machining. Right? Orthogonal machining. If the chip compression ratio is, is 1.25, my dear, then the shear angle, okay, you have to tell me shear angle. Tell me, Question is pretty easy. Yeah, question is pretty easy. You know that tan phi equal to r cos alpha divided by 1 minus r sin alpha. But here 1 by r is given, that is 1.25. Here r is 1 by 1.25 and alpha is 0. So phi equal to tan inverse of 1 by 1.25. Am I clear? If you do the calculation, then the value of the shear angle is 38.65. 38.65 degree. Yes or no? I hope I'm clear. Okay, I hope am I clear to you? Now let's move to the next question. During, my dear, see the question. Question number 3. Till now we have solved 2 questions and it's a question number 3. During a hot working process, the homologous temperature is temperature is 0.8. Okay, the melting point of the work metal is melting point of the work metal is what? 800 degree Celsius. The temperature in degree Celsius, okay, during hot working. Yes, tell me my dear, during hot working what it will be. Yes, tell me what it will be. Basically, recrystallization temperature is 0.8 times of melting temperature in Kelvin. Am I clear? Melting temperature in Kelvin. So the temperature in during hot working, the temperature in during hot working. So 0.8 melting temperature is what? 800 degree Celsius, right? 800 degree Celsius or 800. Basically, you have to find out in what? In Kelvin, na? So directly it will become, okay, directly it will become how much? You can calculate it. 800 into 0.8, it will be 640 Kelvin, 640 degree Celsius, right? 640 degree Celsius. Am I clear? Okay. Now the next question. Yes. The next question is from metrology, right? From metrology. Next question is from metrology. This is question number 3 and this is question number 5. Question number 4. See, in an assembly there is a shaft. Basically, there is a shaft and there is a hole. There is a hole having a size of 25 plus 0.002 and minus 0.001 mm, right? And there is a shaft, having a size 25, plus 0.001, okay, minus 0.003. Am I clear? Minus 0.003. My dear student, you have to tell me type of fit. The type of fit is, the type of fit is, very easy question, yes or no, tell me the type of fit. Tell me which type of fit is that. My dear student, tell me which type of fit is that. Are you listening or not? Tell me which type of fit is that. If you are listening to me, then tell me which type of fit is that. Okay. I used to say, whenever this type of question will come, try to draw a diagram. This is a basic size of what? Of 25. This is a basic size of what? 25. Okay. And this is the hole basically. See, this is the hole of the maximum size. See the maximum size of the hole. See the maximum size. This is the minimum size. The red line is the zero line. Are you getting my point? Now it's time to draw a shaft. Here is the shaft. Now see the shaft. A shaft of, see, this one, this is the maximum size of the shaft, and this is the minimum size of the shaft. See, my dear, see, this is a tolerance zone. The tolerance zone of the shaft and hole are overlapping. So which type of fit is that? Transition fit, interference fit, or clearance fit? Transition fit, my dear. Okay, which type of fit? It is a transition fit, right? Transition fit is that. Tell me yes or no. Am I clear? This is a transition fit, my dear. Okay, now let's move to the next question. Without wasting a single minute, a single second, okay, we have to start the next question, because there are a lot of questions of the production engineering and industrial engineering, and I have to discuss industrial engineering also, right? Industrial engineering also, yes. So here's the question. Let me see. Yes, the next question, that is the question number 5. Question number 5, he is asking about the FCC structure. Right? FCC structure. My dear, FCC structure, he is giving option A, chromium. Is that the option? B, aluminium. Okay. And option C, that is magnesium. The last option is alpha iron. Tell me which option is that? Option B, aluminium having a FCC structure, my dear. Aluminium having a FCC structure, right? Now the next question, that is a question number 6, right? Question number 6, my dear, basically there are two balls in the main channel. By mistake I have drawn the wrong diagram, that's why I am getting the wrong answer. So I am correcting the solution which I had given on the main channel of for this question, for this particular question, right? So let me draw the figure first of all. Let me draw the figure. Yes. This is not a correct figure. Yes, perfect. Perfect figure. See, right? See, so here this is a diameter. See, this is a 3 mm diameter and this is a 4 mm diameter, and this one is the height and depth, you can say 6 mm, right? 6 mm. You have to find the cavity diameter. You have to find the cavity diameter, my dear, right? You have to find the cavity diameter. Let me see whether the figure is correct or not. Otherwise, look, the solution is depend on the figure. Okay, the solution is depend on the figure. Okay, my dear student, see here. If I take this center here, if I take this center here, and if I take this much distance, if I take this much distance, this much, okay, how much is that? This is 1.5 and this is 2. So totally it comes out 3.5 mm. Am I right? Okay. Again, please see, this is what, 2 mm. Okay. This is what, 1.5 mm. And please see, this is 1 basically 5 mm. See here properly, please. This is 1.5 mm, right? So this is the 2 mm. Basically, this is 2 mm, right? This is 1.5 mm. This is 1.5 mm. So how much is that? Okay. Also, you can see this is what? This is also a 2 mm. Am I clear? Am I clear to you, my dear student? Okay, am I clear? But I need that distance, right? What is that distance? Look, please. Are you getting my point? What I'm trying to say? This diameter basically a 4 mm, right? Yes. Now see, this is 2 mm, this is 1.5 mm. So 2 plus 3.5, 3.5, 6 minus 3.5, so it comes out 2.5 mm. Am I clear or not? Am I clear or not? Tell me. This is 2.5 mm. My dear, once you find this distance, you are able to find the diameter of that cavity. Okay, you are able to find out the diameter of that cavity. Okay, so what is the distance? This distance, let's say this distance is x1. Okay, let's find out the x1. So x1 is root of 3.5 square minus 2.5 square. Am I clear to you? Am I clear to you? Yes or no? So what is the value of x1? What is the value of x1? Okay, what is the value of x1, my dear? Here you can see 3.5 square minus 2.5 square, root of answer, that is 2.449 centimeter. Okay, now you have to add 1.5 and 2. Okay, answer plus 1.5 plus 2, it comes out, my dear, it comes out the diameter of the cavity will becomes out 5.94 centimeter. Am I clear? Sir, the crash course on this channel helped me a lot. Thank you very much that the crash course is beneficial to you. You appreciate the thing, and I am very happy that you are appreciating the things. Now, my dear, the next question, okay, the next question Next question. What is the next question? Let me see what is the next question, my dear student. Okay. Yes. Now, there is a theoretical question. I mean, there is a match the following. There is a question of match the following. This is the question number 6. Now, question number 7. Right. Your blessings are required, sir, for a better future. My blessings are always with you, students. Okay, don't worry about that. My blessing will always with you. What you have to do, you have to do work hard. That's it. Now, the next question. Casting method. Casting method. Right. Casting method and product. The casting method and product are given. Right, casting method and products are given. So, what are the casting method? P, Q and R. R is centrifugal casting. Centrifugal casting. Right, centrifugal casting. Q is investment casting. Right, and P, writing is not clear. Continental, I don't know the writing, but it is not required. Don't worry about that. And the product is thin and intricate shape 1. Thin and intricate shape. Okay. Second, hollow axisymmetrical part. Symmetrical part. Right. And the third is slab and strips. I think this one is a conventional casting. I thought it is a conventional. Okay, I am not sure about that, but it is, I think, conventional casting. Okay, conventional casting. So, what is the, pair? What is the pair? Look, in centrifugal casting, we used to produce a hollow symmetrical parts. So, P, Q and R. So, R is going to pair with 2, and investment casting, we produce thin and intricate shapes, that is 1. So, 3 goes with P, right? So, this is your answer. So, question number 7 is over. Now, it's time to solve question number 8. Okay. Now, it's time to solve question number 8, my dear. Now, what is the question number 8? Let me see the question number 8. Just a minute. Okay. Yes. A cylindrical workpiece is tested. Okay. Please listen the question carefully. The question is lengthy and I am not going to write on the board, but I will write the data. Okay. So that you can understand the thing in a very easy manner. Question number, which question is that? Question number 8. Okay. A cylindrical workpiece is turned. Okay, is turned and turned using 2 different tools. Tool 1 is turned using 2 different tools. Okay, using 2 different tools. 2 different tools. Using 2 different tools. Now, there is a tool 1. There is a tool 1. In tool 1, my dear, there is a nose radius of 0, right? And the side cutting edge angle and end cutting edge angle, CS is what? CS is 20 degree, okay, and CE is what? 10 degree. okay, CE is what? 10 degree. Now, if you turn the same workpiece with another tool, that is tool number 2, which having a nose radius, 0.2 mm, right, 0.2 mm, both the tool machine had a feed. In both the machining operation, feed is same, that is 0.2 mm per revolution, and here the feed is also same, that is 0.2 mm per revolution. Are you getting my point? Are you getting what I am saying? Okay. Now, the ratio of ideal maximum height of uneven on the surface produced by tool 1 to, okay, you have to tell me the surface roughness produced here, okay, the surface roughness produced here and the surface roughness produced here. You have to tell me, my dear, H1 by H2. You have to tell me H1 by H2. You know, when the nose radius is 0, okay, and if the side cutting edge and end cutting edge is given, then the surface roughness is what? Feed divided by 10 of side cutting edge angle plus cot of end cutting edge angle. Am I clear? Am I clear, my dear student? Okay. And if the nose radius is given, then the surface roughness is f square divided by 8r n, that is the nose radius. So here is the surface roughness. F feed is 0.2, my dear, divide by 10 of side cutting edge angle, that is 20 degree, plus cot of end cutting edge angle, that is 10 degree, right, 10 degree. Okay, here H2 is what? Feed, that is 0.2 square divided by 8 into nose radius, that is 0.2. Am I clear? Am I clear or not? Okay, let me see whether the nose radius is right or wrong. Yes, has 0.5. Yes, here the data is, here the nose radius is what? 0.5, my dear. Okay, 0.5 square. Nose radius is what? 0.5. Tool 2 has a 0.5 nose radius. Am I clear? So, what is the answer? Okay, what is the answer? So, 1 by, just a minute, 1 divided by 10 of 10 of 10, 1 divided by answer 1 plus 10 of 20, 0.2 divided by answer, here 0.0331 and here 0.5 square divided by 8 into 0.2, here 0.156. You have to find 0.0331 divided by 0.156. So 0.0331 divided by answer. I think there is a little bit calculation mistake. Okay, I think there is a little bit calculation mistake. F square, that is 0.5 square divided by 8 into R. F square. Oh, yes, I have put the wrong value. F square, that is 0.2 square, 8 into R, that is 0.5. Now the thing is right. So 0.2 square divided by 0.2 square divided by 8 into 0.5, it comes out 0.01. So here it comes out 0.01. So it will be 3.331. Right, 3.331. Clear? So this is a question number 8. Now let's move to the another question. And another question, that is the question number 9. Question number 9, my dear student, and here's the question number 9. Question number 9 says, in injection blow molding of plastic beverage bottle in injection blow, okay, blow molding of, in injection blow molding of plastic beverage plastic beverage bottle, right, bottles, the blowing is accomplished by, the blowing is accomplished by, okay, the blowing is accomplished by which method you accomplish the blowing, okay, okay. So here is the option A, option B, option C, and option D. Option A is alcohol, okay, alcohol. Option B is what? Option B is hot water, okay. Option B is hot water. Option C is hot air, my dear student, hot air, right. Option D, hot oil, okay, hot oil. So which one is the option? Hot air is the option, okay. यहाँ कौन कौन गेट की तैयारी करना चाहता है? Okay, so option C is the answer. Now I am coming to the question number 9. Okay, I am coming to the question number 9. So here is the question number 9. Yes, in a gas tungsten arc welding process, just a minute. Yes. In a question number 9. In a gas tungsten arc welding process. Okay. Process under steady state condition, under steady state condition, okay, the instant So I hope now my voice is clear. I hope my voice is clear. Okay, because the battery was down, that's why the voice is not clear and coming. So my dear, how can you solve? How can you solve? What is basically a power which you are giving, that is I into V, and how much? 160 into what? What is the voltage and current? 18 watt, right? Now if 40% is going to be loss, if 40% is going to be lost, then how much will be left? How much will be left? Okay, actual available power, okay, 60% will be available now. 60% of what? 160 into 18, and here 800 watt is also loss. So net power, yes, your answer is right, 928 watt. 928 watt is available. Clear? 928 available. Now, question number 10, my dear. I have solved 9 questions. Now, here is the question number 10. A most interesting, most difficult, and a very good question, okay, in the production is question number 10, which I am going to write on the board. And I am going to write each and every line of that question because it is a very good question, right? Because it is a very, very good question. So please listen me carefully. Question number 10, a very good question. For an electrochemical machining process, for an electrochemical machining process, okay, equation is given, that is a dy by dt equal to lambda by, okay, y minus f, right, minus f. So this equation is given, okay, where, my dear, where y is what? Y is the inter-electrode gap, where y is the inter-electrode gap, okay, y is what? Inter-electrode gap, right? Y is a inter-electrode gap, okay, in mm, okay, at time t in minute, at time t in minute, okay, in minute. F is a feed of the tool, F is the feed of the tool, F is what? Feed of the tool. Am I right? Feed of the tool. Okay, in mm per minute. My dear, this question is very important, that's why I am writing, otherwise I will not write. Okay, the value of lambda, how much? 6 into 10 to the power minus 3 centimeter square per minute, right? For maintaining a constant inter-electrode gap, for maintaining a constant inter-electrode gap, gap is how much? 0.1 mm, right? The feed in mm per minute should be, right? Am I clear? Is that question is clear? Tell me, yes or no? First of all, tell me, is that question is clear to you people? Yes or no? Yes, my dear. Tell me, is that question is clear? If you people are not going to respond, I am not going to solve this question. Right? I am not going to solve this question. Tell me, is that question is clear? Yes or no? Okay. Now here, see, the solution is pretty simple. Because you have to maintain the gap, okay, because you have to maintain the gap in between the electrode and workpiece with respect to time. In that case, dy by dt will be what? 0. Y is not going to be vary with respect to time. So it is 0. For a steady state condition, the gap is uniform. Solution. Solution is for steady state condition, steady state condition, for steady state condition, the gap is what? The gap is 0. Sorry, the gap is maintained. The gap is maintained. If the gap is maintained, then dy by dt, okay, if the gap is maintained, then dy by dt is equal to what? 0. Am I correct? Okay. If dy by dt is equal to 0, then lambda by y equal to what? F. So now you are able to find the value of feet. So here the value of feet, here lambda, the value of lambda is 6 into 10 to the power minus 3 centimeter square per minute. So 6 into 10 to the power minus 3 centimeter square. I am going to convert into the mm square. So it is mm square per minute, my dear. Divide by lambda, divide by y, divide by y, okay, y is what? 0.1. So it will become 6 mm per minute. Yes or no? Tell me. Yes or no? Tell me. Is that solution is clear to you people? Shall I move further? Yes. Shall I move further? Okay. Now I am going to move further. Right. Now I am going to move further. Shaft of, no, it is a theory of machine. Next question is the work table. Yes, the next question is from NC-CNC. The next question is from NC-CNC, my dear student. See here, right? See here. See here. Question number. This is question number 11. Question number 11. Okay. There are a lot of questions asked in PI paper of production. The work table of an open loop positioning system, the work table of an open loop, okay, open loop positioning system, positioning system, okay, positioning system is driven by a lead screw, by a lead screw with a pitch of how much? 4 mm. 4 mm, right? 4 mm. The lead screw is connected to the lead screw is connected to the, okay, is connected to the shaft of a stepper motor. Shaft of stepper motor, shaft of a stepper motor. Okay, a gear of 80 teeth mounted, 80 teeth mounted, Okay, 80 teeth mounted on the stepper motor shaft, on the stepper motor shaft, right? Meshes with gear of 20 teeth mounted. 20 teeth mounted. Am I clear? 20 teeth mounted. Okay, 20 teeth mounted. Okay, on the lead screw. On the lead screw. Okay, on the lead screw. The step angle of the stepper motor is the step angle of the stepper motor is okay, of the motor is 9 degree. This type of question I have solved many times. Motor is what? 9 degree. Okay, 9 degree. The number of pulse, required, okay, required to move the table, by 200 mm. Yes. Look, I am not going to solve this question. This is a very easy question. First of all, find out the number of pulse which is required. Okay, the number of pulse which is required, okay, for one rotation of the shaft, or find out the number of pulse which is required to move 4 mm linear pitch. Then for 200 mm, how much pulse is required? Very simple, right? So this question is pretty simple, and I am not going to solve this question. Clear? Now, the next question is, yes, there is a next question. Question number 12. Question number 12, right? Question number 12. What is the question number 12? In an EDM, process, the discharge voltage, is VB. Okay, VB, the discharge voltage VB, the energy dissipated per arc. I mean, he is asking that the spark energy, which produces in a cycle is proportional to, yes, we know that energy which is produces in one cycle is half C VB square. So energy is proportional to what? VB square. Simple. What number of the MSQ we have expected in civil and mechanical? We will discuss after the discussion of your paper. Okay, after the discussion of after the discussion of questions in your paper, then after we will discuss. Don't worry about that. And And yes, last question, okay, which I am going to solve. Last question which I am going to solve in manufacturing is, okay, which I am going to solve in manufacturing is, see here. See here. See the number, see the question. Question. This is what 12, this is the 13th question. This is the 13th question. During a straight turning, during a straight turning, during a straight turning of a 20 mm, of a 20 mm dia steel bar at a spindle speed of 400 rpm, 400 rpm, ठीक है भाई, okay, with an HSS tool, with an HSS tool, a tool life of 10 minutes, right? A tool life of what? 10 minutes was observed. Okay. When the same bar was turned at, when the same bar was turned at 200 rpm, right, 200 rpm, the tool life increases, the tool life increases to 40 minutes, right, to 40 minutes. Are you getting my point? Okay, are you getting my point? 40 minutes. The tool life in minute while machine the bar, okay, machine the bar at 300 rpm. Again, this question is very easy. Okay, again the question is very easy. Tell me yes or no. Basically, you have to apply the Taylor equation, right? You have to apply the Taylor equation. Very simple. You can write that V1 T1 to the power n equal to V2 T2 to the power n, or you can write N1 T1 to the power n equal to N2 T2 to the power n. And here N1 is given, that is a 400, okay, and T1 is 10 to the power n. N2 is given, and N2 is, that is a 200, and T2 is what? T2 is 40 to the power n. If you solve this equation, you will get n equal to, I think, 0.5. Please check yourself. 18 minutes nearest. Yeah. Yes, Uttam Kumar, you are right perfectly. Your answer is perfect. Okay. So n is 0.5. So again, if you write N1 T1 to the power n equal to N3 T3 to the power n, and if you put the value, N1 is what? N1 is a 400, my dear student, and T1 is again the 10 to the power 0.5, N3 is 300, okay, and T3 you have to find out, okay, and it will become, T3 will become 17.7 7 minutes. Am I clear? Am I clear all? Am I clear to all? Am I clear? Yes or no? Please tell me. So this is all about the production. Okay, this is all about the production. Some few questions are not available with us, so that's why we are not able to solve that question. Now, let's solve some other questions. I mean, let's solve industrial engineering. Whatever questions are available to me, I am going to solve. Okay, I am going to solve that questions. Okay. The first question in industrial engineering is, let me see. Yes, the control chart. Okay. Now I am going to start industrial, right? Now I am going to start industrial. Okay, industrial. I have completed production. As you can see, I have completed production. Okay, we have completed production. Got it? We have completed the production. Now I am going to start industrial engineering. Right? I am going to start industrial engineering. Now see. Okay, shall we start? Are you ready? Okay. Look, the first question is a theoretical question. The first question is a theoretical question. And what is that? The control chart. The control chart. Okay. Oh, P chart for a defect. Okay. You already know? Huh? You already know that? It's good. You already know that? Let me see the question. Basically, the question is not clear in my phone. So, I will see on my screen. Right? I will see on my screen because the question is not visible. The question is not visible on my screen perfectly. So, I will see. Yes, P chart for a defect. Yeah, percentage defect. Very good. Yeah, the control chart. The control chart for number of defect for a number of defect in a weld joint. In a weld joint is, what is that? Tell me, which chart will you prefer? Which chart will you prefer? A. C chart? Tell me. In a control chart, the number of defects. Beta, the number of defects. A, B. Yes, B. P chart, C. X bar chart, D, R chart. Tell me which chart? Uttam Kumar, it's not a P chart. P will give the percentage defect. Uttam Kumar, P gives the percentage defect, a fractional defect. Are you getting my point, Uttam Kumar? P gives the fractional defect. So, P will not the answer. I think the C chart is the answer. Am I right, Uttam Kumar? Am I right? The C chart will be the answer. Okay. Now, let's move to the next question of the industrial engineering. A cylindrical, okay, in a bar, 180, a shaft, the work table in okay, थ्योरी पे इतना फोकस नहीं किया, कोई बात नहीं, it's okay. If you remember, then okay. If you not remember, then it's okay, यार. These are some small things. Okay, if you forget, we are humans, yeah. We can't learn each and everything. We can't remember each and everything. After all, we are a human. We are not a machine. Okay. Okay. Now, I have a few questions of industrial engineering, not more questions in my phone. So don't worry, I am not going to run this session very long. I have hardly 2 or 3 questions in my phone. So I am going to solve 2 or 3 questions, then after I am going to close this session. Okay. Now, the another question from forecasting. Okay. The another question is from forecasting, my dear. So here is the another question. Let's see. What he says there is a forecasting. Okay. Here smoothing constant, alpha is a smoothing constant is given. Alpha is a smoothing constant is given, that is 0.2. I am not writing each and every line. Okay. I am not writing each and every line. Alpha is a smoothing constant which is given to us, my dear, and actual demand with respect to the week. This is the actual demand. Okay. And this is the forecasting. This is what? This is the forecasting. Now, week 1, week 2, week 3, week 4. Week 1, week 2, week 3 and week 4 and week 5. Am I clear? Yeah, forecasting. Now, here it is given that in a week the actual demand is 375, right? 375. 4, I think it's a 412 or 422. This is not clear to me. I am assuming it is a 422. It may be a 412 also. Can you tell me, is that data is correct? It is a 422 or 412? 592, 592 and 439. 439. Can you please tell me, is that data is correct? It is 422 or 412? I think 422. Okay. Now, it is given that the forecasted demand for week 3 was yes, week 3 was, the forecasting demand for the week 3 was 500, right? You have to find out forecasting for the week 5. Okay. So my dear, what is the value of F4? F4 is what? F4 is what? Tell me the value of F4. F4 is what? F3 plus alpha into D4 minus D3 minus F3. Am I clear? D3 minus F3. So what is the value? It is, I think, 518. 518. Okay, 518.4. You have a F3, you have a D3, okay, you have a alpha. Now, you have to find F5. Again, F5 is what? F4 plus alpha times of D4 minus F4. It will becomes out 502.52. Am I clear? Need only third and next demand data. Yes. So that's it. Okay, it's finished, my dear. It's finished. Now, the next question. Okay, the next question is, what is the next question? Let's see. What is the next question? Okay, what is the next question? Here, activity and variance. Activity, expected duration, and variance is given. Right? Activity, expected duration and variance is given. Right? So 1 A, B, C, D, E, F and G, right? So these are the activity, okay, and the duration is 4, 5, expected duration 4, 1, 7, 6, 8. Variance is 1, 1, 1, 0, 4, 1, 4. This is a variance. Right? Now, my dear, here critical path, on a critical path, which activities are there? Critical path consists of activity BEF. Critical path consists of activity BEF. Critical path consists of activity B, E and F, right? What is, you have to find the standard deviation of the project duration is, okay, variance, the expected time in minute, my dear, right? Variance is also in, I think, minute, okay. The standard deviation, you have to tell me the standard deviation in minute of the project duration is, of the project duration is, yes please. Standard deviation 3 answer, very good. Look, we know that standard deviation is root of variance on critical path, summation of variance on critical path, am I right? So here see, on a critical path BEF, activity B, E and F, BE pakka, B, E, I think it is G, BEG, let me check. Yes, it is a BEG. So not F, my dear. On a critical path, sir, variance minute square होगा, हाँ वही तो, हाँ. So on a critical path BEG, on a critical path BEG are the activity which are lying. So what is the variance? 1 plus 4 plus 4, that is 3, right? That is 3. Am I clear? Am I clear, my dear student? Am I clear? Yes or no? Tell me. Am I clear? Yes or no? Okay. Now, let's move to the next question. Okay, let's move to the next question. Let's move to the next question. Yes. Let's move to the next question. Basically, a company produces 24 cars per day, right? Setup cost is what? Setup cost is 1947 rupees million. Okay. Variable cost and selling cost. Variable cost is what? Rupees 0.6 million per car. Selling price rupees 1.5 million per car. Right? Right. Now, what he is asking, the number of day required for achieving the break even. The number of day required for the number of days required of achieving break even point. Yes or no? Clear? Okay. You know the break even quantity, break even point or a break even quantity is what? Fixed cost divided by selling price minus variable cost. So it will become 19476 divided by 1.5 minus 0.6. It will becomes out, my dear, it will becomes out 21633. Okay, 21633.33 cars. Right. Right. If he produced 24 cars in one day, then how much time he will take to produce 21633.33 cars? Right? How much time it will be required? It will be 901.38. 901.38 days are required. Yes or no? Am I clear? Am I clear? Yes. Okay. Now, the last question of this session is, yes, the last question of this session, right? Please see. So this is the last question of this session. Question. In a machine, there are two motors. There are two motors. Okay. But only one motor, is needed. For the functioning. Right, for the functioning of the machine. Right. The reliability of the motor are of the motors are 0.4, I think, 0.402 and 0.7. please check whether the data is correct or not. 0.402, okay, and 0.7. The overall reliability of the machine, reliability of machine is, yes please, yes, my dear, here the motor are connected in parallel, because in the system only one motor is going to be what? In the system only one motor is going to be what? Used, right? In the system only one motor is going to be what? Used. So if there is a one motor going to be used, so what will be the reliability? Tell me, yes or no? Either motor 1 or either motor 2. So only one motor is going to be what? Is going to be used in the system. Yes or no? According to the question, are you getting the thing or no? Tell me first of all. Tell me, my dear student. Okay, tell me. Tell me. I think it is a 0.9. It is 0.9. I think it is 0.9. 0.9. Okay. So only one motor is going to be used. Reliability when the system is parallel. Okay. Here, reliability when the system is parallel, reliability when the system is parallel. And how should I know? How should I know that the system is parallel? Because he says only one motor is capable to operate the system, right? So the formula is 1 minus reliability of machine 1 into 1 minus reliability of machine 2. Am I clear? So 1 minus, just do the calculation, 1 minus 0.9, 1 minus 0.7. So 1 minus 0.9, answer into 1 minus 0.7. Okay, 1 minus answer 0.97. Reliability is what? 0.97. So that's it, my dear student. I have only that much question which are memory based. Maybe some data will be wrong, but the concepts are right. Thank you for watching this session. Okay, we will meet soon in the mechanical session. If you people are giving a mechanical paper on 30th Feb, then we are going to meet soon. Okay, thank you for watching this session.